Welcome to ASU's University Academic Success Programs. This video will cover the topic, functional groups. In organic chemistry, we focus on organic molecules, where the main components are carbon and hydrogen atoms. When atoms such as oxygen and nitrogen are brought into the picture, we get functional groups.
What's the importance of functional groups?
Functional groups are where chemistry happens. In this video, we will discuss a few important functional groups. First, let's look at the hydrocarbon backbone of many organic molecules. Alkanes consist of carbon and hydrogen atoms and consist only of single bonds. The simplest alkane is methane. We could make a longer chain, and if we put an R on one or both ends, this indicates any alkyl chain as a continuation of the drawn molecule. The bonds within alkanes are strong, which means they're not very reactive and have little biological activity. However, we often find functional groups attached to alkyl chains. When we attach an alkyl chain to a carbon or nitrogen, we call this a substituent. The number of substituents determines the notation of the atom we attach them to. A primary carbon has one substituent. A secondary carbon has two substituents. A tertiary carbon has three substituents. And a quaternary carbon has four substituents.
What if we have a chain with a double bond between carbons? Is there a different name?
There is. If we have a carbon-carbon double bond, this is called an alkene. The simplest alkene is ethylene. Sometimes we will see a structure like this. We may be tempted to think that this is a cyclic alkene, but it's really a unique structure called a benzene ring. The benzene ring corresponds to the aromatic functional group, which consists of alternating carbon-carbon single bonds and carbon-carbon double bonds in a ring. While we denote the alkyl chain substituent with an R, we can denote an aromatic substituent with an AR. Now, we've looked at carbon-carbon double bonds, and we can even have a chain with a triple bond between carbons. This is called an alkyne. The simplest alkene was ethylene, and the simplest alkyne is ethyne. Now let's see what happens when we introduce atoms other than hydrogen and carbon. If we replace a hydrogen somewhere on the chain with a halogen, we call this a halide functional group. Here, the X stands for any halogen. For example, this is called chloroethane. Now let's take a look at what happens when we introduce nitrogen to the picture. The amine functional group contains a nitrogen and has at least one alkyl group. This is one functional group where we must label it as primary, secondary, or tertiary. For example, methylamine is a primary amine because the nitrogen is bonded to two hydrogen atoms and a methyl group. When carbon shares a triple bond with nitrogen, this is called a nitrile. For example, acetonitrile features two carbon atoms where one is triple bonded to nitrogen. Next, looking at functional groups that contain oxygen, the alcohol functional group is an oxygen bonded to one hydrogen in an alkyl or aryl group. For example, we take a look at propanol, and we see that we have an oxygen bonded to a hydrogen and a propyl group.
Why do we write out the hydrogen bonded to the oxygen, but none of the hydrogen bonded to carbons?
When we draw line angle structures, we don't include hydrogen atoms unless they are part of a functional group. Since the hydrogen here is part of the alcohol functional group, we must include it. Moving on, the ether functional group consists of an oxygen bonded to two R or AR groups. An example of this is diethyl ether. The epoxide functional group looks similar, but instead consists of a three-membered ring containing oxygen. There are a few functional groups where carbon and oxygen share a double bond. When we see a carbon-oxygen double bond with an R or Ar group and one hydrogen, this is an aldehyde. For example, acetaldehyde has a methyl group bonded to the central carbon of the aldehyde. A ketone looks similar to an aldehyde, except there are no hydrogens bonded to the central carbon. The simplest ketone is acetone, where the carbon is bonded to two methyl groups and double bonded to an oxygen. Carboxylic acids consist of a carbon-oxygen double bond where the central carbon is then bonded with an R or Ar group and an alcohol group. For example, acetic acid is a carboxylic acid with a methyl group bonded to the central carbon. Esters look similar to carboxylic acids, but instead of an alcohol group and an R group, the central carbon is bonded to an OR group and an R group. For example, ethyl propanoate consists of a main chain with 3 carbon atoms and an ethyl group bonded to the oxygen. If a carbon shares a double bond with oxygen and is also bonded to a nitrogen, we call this functional group an amide. Amides are classified as primary or secondary. For example, this is a secondary amide because the nitrogen is bonded to an ethyl group and a hydrogen. The last functional group we will look at is the acid-halide functional group. Acid halides feature a carbon that shares a double bond with an oxygen and single bonds with a halogen and an R group. For example, acetyl chloride is an acid halide with chlorine as the halogen.
So it sounds like there are many functional groups we must take into consideration in organic chemistry. Basic alkanes are very strong and fairly unreactive, but when we begin adding functional groups to a hydrocarbon chain, more chemical reactions are able to take place.
That's exactly right. Great work!